Okay, so we're talking of a summarized subnet where we want to have an ACE that permits traffic from all these networks. One ACE that permits traffic from all these networks. Not only one, but buttons are ASR3. So ACE redu rinenge rakaita sei? So ACE redu richada the network, then richada the wildcard mask. Network yacho inenge yakaita sei? But that's the part I'm going to look at. Pana. I think tatanga nokutsvaga the wildcard mask, but with network yacho inenge yakaita sei, which summarizes my networks ASI. So network yedu inobuda yakaita something like this. So pese pakafanana, panofanira kuramba pakafanana. For example, we have 192 uniform permanent SR3, 168 uniform permanent ese, but panapa ndo parosiyana apa. We want to see which parts are the same for all the three networks. So I'll go to my bits again, 16, 17, and 31. 1, 2, 3, 16. Why did I delete that? Then 1, 2, 3, 17. 1, 2, 3. This is 31. So I'm looking for the part yakafanana for all the three networks. The part yakafanana for all the three networks is this part. 0, 0, 0, 1. Then is now fanana. I can put zeros like this. So this value is, that's a 16. Dot 0 slash, since my values are fanana, will represent my network portion. It means network portion yangu irikugumira panapa. Network portion yangu ikagumira apa. It's 8, 16 plus 4. Is that a slash 20? That's a slash 20. So network ish. No network summarize zvese zviri apa izvi. Is it making sense? Is it correct, by the way? Let me see. Slash 20. Tikazoda kutsvaga the wildcard mask. Slash 20 is 255, 255, 816, 4. This is 240 dot 0. Tikazoda subtract from 255, 255, 255, 255. I get 0, 0, 255 minus 40, 15, 255. I think this is correct. Ndo mask yatambobudisa wildcard mask yatambobudisa iyi. So to repeat, kuti zvinyatsomake sense, as if it wasn't. To repeat, kuti zvinyatsomake sense, I think ndo pakutsvaga mawildcard mask ndo part ringori trick iyi ine ma-summarized networks. So if you want to match a host, this is what you do. If you want to match a network, suppose you have a network, let's use not slash 23, let's use slash 25. I want to match a network. Permit or deny everything chiripa network up. What do I do? ACE rangu will look like this. Permit ndotora network yangu 192.168.10.0. But panapa ndafanira kuisa the wildcard mask. Mask yangu ndonoiwana nekutarisa this slash 25. Slash 25 is 255, 255, that's 16, 255, that's 24, 128, that's 25. Then I subtract from quad 255. If I subtract from quad 255, I get a 0 here, 0 here, 0 here. Then 255 minus 128, that's 127. Meaning, per ACE rangu, a value wildcard mask in panapa, it's 0, 0, 0, 1, 27. Meaning, iri statement iri will permit every host from this network. So Yema networks, I think it's very easy. Subtract the quad 255, the subnet mask from quad 255. Then the last one, you do now to summarize my networks. So let's use the same example again. /24, 17, /24, 31, /24. So in the three my networks are, I want to have an ACE which permits traffic from all the three. All the three. So one ACE, one statement. So what do I do? I summarize. I summarize these networks. Summarize these networks. You find the part yakafana. Pa three my networks are. The part yakafana pa my networks are is 192, 168. Obvious, yakafanana. But from here, we have my beats mamwe akafanana mamwe akasiyana pa 16, 17, and 31. That's why we came here and did this. This is 16. This is 17. And no. This is 31. Ndikadata mabhitsi ari kumecha akafanana. These are the ones ari kumecha aya. Meaning ndo parogumira network portion yangu apo. Pana 0001. Then kana iri network portion yangu kunokama 0. Then this value ish ndo yandiri kunza panapa. This is 30, 32. Is that 32? 16. That's 16. 16. Then dot 0 slash network mask yangu yakuita chii, since portion iri rakuhost iri rese iri pandasummarize iri, in meaning when I have a slash trend here. So iyi ndo inonzi summarize network ichi. So ndikazoenda ndikaisa AC rangu rakanzi permit 192 168 16 0 ne-wildcard mask randinowana nekusubtract quad 255 from /20. So 255, 255, 255, 255, /20 is 255, 255, that's 16, 240, 240. So this is /20, 240. I think this is 0. If I subtract, I get a 0, 0, 0, 15, 255. Ndo yandinounza pano 0, 0, 15, 255. So basically, statement E by ACL, what does it do? It permits every host from all these three networks. As simple as that. I think your summarizer is the most complicated. Yema host, Yema networks, simple. Let's look at another one. Which other one do we have? Wildcard mask calculation. I think we've just calculated my mask. Is there an example at Snapchat? This one, we want an ACE number 10, which permits access to this network, /24. /24 network, rinobudisa ish, ndo wildcard mask yayo. It should be very familiar to you because the /24 network, I think, inoshandiswa zvingaita pasizionei. We want to create another ACE 10 for that network, /28. /28, that's 255, 255, 255, 24 plus 4, 240. I think that's /28. Then if you subtract quad 255, you get 0, 0, 0, 15. Ndo ichi chipuka chirapa ichi. Then we have another ACE, number 10, to permit only networks 10.0 and 11.0. That's another summarized network. let's summarize it. Tony, that's another example. So we want to have a an ACE that permits 192.168.10.0/24, 192.168.11.0/24. So ndodaona a summarize network up. How do we get it? The paths akafanana patuma address 192 both 168 both, then panapa we have mabits mamwe akafanana mamwe hana. So which parts dzakafanana nedzisina? 1 2 3 4 8, that's 10, 8, that's 11. So the parts dzakafanana we can see that 0 0 0 0 1 0 1. I think kusvika up same thing, is it not? Kweso kwakafanana, meaning ndo the network portion yangu iyi. So network portion yangu yakati 0 0 0 0 1 0 1 because kwakafanana. Then here yakutoita host portion pakutoiswa 0, the rest ama 0. Value iyi pa 8 bits yangu it's 8, that's 10. So panapa 10 is common, then 0 panapa. What will become my mask since network portion yangu irigumira up? So it's 8 16 plus 7. 16 plus 7, that's 23. 7 ayarapai. Plus 16 ayarapai. That's 23. It now becomes a /23. So if then summarize subnet here. Kana waona summarize subnet, it's very easy now to have your ACE. ACE rako rauya kuti permit 192.168.10.0/23 word mask raro roya roti 0 0. Let me see, /23 is 255 255, that's 16. 7, what do we get pama 179? 254. Is that not 254? Those /23.0 in those /23. So if I subtract quad, I get 0 0 255 minus 254 1 255. Therefore panapa is 0 0 1 255. I hope this is correct. So ndikaisa ACE rakadai irirapai, then every host from these two networks will be allowed, permitted on the interface by AC already. Let's see, 0 0 1 255. 0 0 1 ndo parobva manumbers aya. 0 0 1 255. It's as easy as that. Wildcard mask keywords. Instead of using quad 4, you can use the keyword host. I think we'll see that patiyatanga labs yedu. Instead of using quad 255, you can use any. Quad 255 is basically matching any address. Ignore the entire IPv4 address or accept any address. Right, guide for ACL creations. Limited number of ACLs. Right. In ACL, you can have only one ACL per interface. You can only have one ACL per interface. It's actually two. So you can have one outbound, then one inbound. On a given interface. Is this making sense? One outbound. Let me see. Let me make sense out of this. There's a limit to the number of ACLs that can be applied on a router interface. A jaw-stacked interface can have up to four ACLs applied. So current version suggests IPv4. It basically means an interface can have a maximum of two ACLs, one inbound and one outbound. So pakuisa ma-ACLs, applying ma-ACLs akho, you need to know what interface. So for example, interface ir, interface iri, unokwanisa kuisa one inbound and one outbound. Wakwanisa kuisa multiple, wakwanisa ku-apply multiple ACLs on those interfaces. I think another thing that makes sense, can I do with my lips, that one. Best practices, base ACLs on organizational security policies, write out what you want, use text editor to create, edit, save, document ACLs, test. So these ones are basically guidelines uh, which prevents you from having a disaster. My ACLs can be a disaster to my networks if configured incorrectly. They can be a disaster kuma networks because small mistake network yese imwe inogona kufarirwa panze oro yako yo network inofarirwa panze because of you didn't configure ACL yako well. So best practices, one, you have to work with my policies of your organization yenyu iri kuti munhu wese ngaasaende painternet, iri kuti munhu wese ngaasaende pafacebook. That's an ACL that can be used. Of course, we have more forms of filtering, URL filtering, and all, but an ACL can be used. Ukapinda pa network. I know currently if I use it, there are websites dzosingakwanisi kuenda pauzvo. So wakaenda wakanobloga port 80, it means hauchakwanisa kubrowse anything. For websites specifically, I think those are my firewalls are block via my URL filtering, application filtering. But my ACLs to a certain extent for my services that we can define at layer 4 anokwanisa kuvharwa nema ACLs. So you just follow my policies, my security policies organization kuti vari kuti hatitoda munhu anoenda pafacebook, hatitoda munhu anostreama, then my ACLs ako will be according to those policies. Write out what you want the ACL to do. Make sure uri kunyatsoziva kuti ACL rauri kuda kuzoisa what is it going to do, because if you confuse izvozvo, that's a problem. Document. The purpose of documentation, I think we now understand it. We've been documenting from, I think, my interfaces, some descriptions. That's part of documenting. I think it's important kuti vanhu vazive kuti ACE raiswa, what is it doing? It's blocking traffic from network A, B, and C. That's documenting my ACO wako. So if someone is using, can you yourself, if you are using that network, assurance, for example, you can see with ACO rauka is what does it basically do. Then testing my ACOs, test my ACOs kuti uone kuti haunovharira manetworks panze asofana ovharirwa basically. Best practices. I think these ones come with experience. ACL handifungi kuti rinojairika zvekudaro. This one definitely comes with experience. Standard versus extended. I think we've discussed this one. Standard source IP, extended IP protocol, port numbers, protocol type, port numbers. Then we have manumbered and named ACLs. Manumbered, they use my numbers. So you have my standard using these numbers, my standard ACLs. So these are for the number standard ACLs. Then we have these ones. Do my extended if you're using my numbered, which I don't think we'll be using much because this is more of a traditional traditional way of having my ACOs here. It's very difficult. It's not difficult. It's a bit complex in the sense that editing. If you want to change or add, nobody will block a network A. Wakuda kuedera kuti ndauda block a network B. Then you have to change everything. You have to change everything. Delete ACO Rangwamboisa. That's the thing with my numbered ACOs. I think Pachetama Labs will demonstrate this as well. My named, on the other hand, they're a bit flexible. You could just add a Porongo editor, you could add another sequence number or is another statement. Then my statements UI could work perfectly instead of deleting almost everything. So my named and numbered ACOs, these are just types of my ACOs that we have. My numbered will really be using the match because of how rigid they are. My named ACOs on the other end, very flexible, very descriptive, easily editable. You can easily edit my named ACOs, very easy. Let's look at what else. Where to place my ACOs. This is also important, very. Where do you place your ACL? So we've discussed inbound and outbound. Now we're going to look at placement. Standard LCLs should be located as close as possible to the destination. Why? Because my standard LCLs, they deal with my source IPs. Do I have an example? Let me deal with an example. Right, let me deal with an example. Right. Placement in my standard LCOs, close to destination. We basically want to look at why close to the destination. So you realize that if I have my standard LCOs, they are only using source IP addresses. So if you locate them very close to the source, what will happen is you potentially block traffic you also block. So for example, let's look at this one. In the figure, administrator wants to prevent traffic originating from 192.10.0. 10.0, this is 10.0 from reaching 192.168.30. So traffic from this one, aisirufana kusvika uko. So traffic is aisirufana kusvika kunoko. We want to have an ACL which restricts traffic from 10.0 kuti isasvike uko. If we're using a standard ACL, and you place it close to the source, recommendation is close to the destination. Where you place it close to the source, what could happen? So for example, ukayokarisa panapa, very close to the source, pa network yacho chaiko ipo, what will happen is traffic yese from this network aichatobudi kuendako yese from this network. So for example, hatina kudhinaya kuti iuye kunoko kunetwork ichi, hatitoda kuidhinaya ikoko, but iwewo ukangoisa ACL rako very close here, then traffic iyoyo haichatokwanisa kusvika kunoko, haichatokwanisa kusvika kwesoko haichasvikoko because waisa very close to the source. So the idea is to place traffic iyoyo closer to the destination. Closer to the destination. Why? Because in the case, for example, where it's exactly placed panapa. ndikaisa eh, ndikaisa panapa. Okay, example iyi, I think this is close to the destiny, close to source, inbound here. So this is our inbound, iri outbound here, close to destination here. I think ndo akashandiswa paexample redu rinori. So ACL uri kuiswa parouter 3 apa. Ukaisa ACL riri inbound close to the source, what will happen is traffic yese iri kublock. Traffic yese from this network iri kublock panapa. Zvireva kuti panapa ichasvika, zvireva kuti even kunetwork iyi haichasvika as well. But network iyi hainodefinwa kunzi haisi kufanira kusasvika network, kusasvika traffic from this network. So error iyoyo inenge yaitika apo. So to correct that, placement yako will need to be here, close to the destination. Why? Because ACO rako rinovharira, hey bana, which one is this one? ACO rako rinovharira traffic kuti isasvike panapa and only panapa chete, because panapa rinosvika apa, kunoko rinosvika uko, but parinenge rakuda kuenda uko rinovhara vharwa panapa. So standard rinofanira iswa very close to the destination for those reasons. Then however ukada tarisisa problem yarinayo ndeyekuti, let's say for example traffic iri destined for this network, router iri kuprocess it, vaprocessa traffic yacho yobva yavharwa panapa. It means router redu is processing unnecessary traffic, but it is what it is, no standard SEO. On the flip side, you have my extended, excuse me. Yeah, my voice is gone. On the flip side, you have my extended. These ones underscore very close to the source. And the reason why is because they are very precise. So let's take, do we have an example? There are two possible interfaces. Let's see an example, extended SEO. Right. We have company A wants to deny Telnet and FTP. So we want to deny Telnet and FTP to company B. From there, 192.11 network while permitting all other traffic. So we're just denying this one. So you're going to realize just extended. Let's go up. Okay, Arnaco is extended there. So just extended Ruba from this network, denying FTP and Telnet. ACE redu tikarisa panapa, very close to the source. You're going to realize that it denies only these two, but every other type of traffic will be allowed. Ukadarisa ku exit kunoko, it means we shall allow FTP netelnet kuti isvike panapa. Yoprocesswa yaprocesswa izvo yoblockwa panapa, which doesn't make sense because you're allowing router rako to process unnecessary traffic basically. So if you take a look at it, extended FCO, it explicitly defines zviri kufanira kupermitwa or to be denied by the network to an extent yekuti zvinotofanira kuiswa very close to the source kana uri kuda kuvhara pauda kuvhara. This is very close to the source. On the other end, standard, it's not as explicit or implicit, not sure. It's not as explicit. Saka tinoisa very close to the destination kuti traffic isasvike or isvike kudestination according to our ACL. And I think basically ndo I think my concepts ACL edu. There isn't much panapa. In summary, I think zvinhu zviri key is understanding kuti tine standard, tine extended. Standard ndere IP source, then extended, it covers my layer 3, layer 4 addresses, source, destination, IP, and port numbers. Also important to understand application a wildcard mask. Also important to know about placement. It can either be inbound or outbound. Inbound ndeyekuti uvhare zvinhu zvisati zvapinda murouter zvisati zvaprocesswa. Outbound ndeyekuti uvhare zvatomboprocesswa nerouter basically. And I think if you understand this is what CSH, you are good to go with my ACLs. And with that, I think I can conclude this session.